So when Andy and Betsy are at exactly the same distance from the starting point, let's assume that Betsy has traveled X hours. So accordingly, Andy would have traveled X plus 1 hours. And then the distance traveled by Betsy would be 12x, while that of Andy would be 8x plus 1. And we see that these two are equal. Solving this equation, I can see that x is just 2. So after 2 hours from 2:30, we have the answer as E. So we would have 2 boxes, and each would contain peanut, cashew, and almond. For the first box, I can see that the weight is 10 pounds, right? For the second box, we are not sure, so I can set it to be X. And then the total of these 2 boxes would have a weight of 10 plus X pounds. Okay, so how many peanuts are there in the first box? We can see that because it's 50%. So I know that it would be 5. And about cashew, it would be 2. And for almond, well, it would be 3. Okay. And also for the percentage for the second box, I can see that the peanut would be 0.2x, cashew would be 0.4x, and almond would be 0.4x as well. Okay, and then in the total, I can see that the total weight of peanuts would be 5 plus 0.2x, okay, and that of cashew would be 2 plus 0.4x, 5.2x, sorry. Okay, and then we also have this condition. The new nut mix, which is the total, would have 40% of peanuts, saying that 5 plus 0.2x over the new mix would be 10 plus x, would be 40%. Okay, we can solve for this equation. So this would be 5 plus 0.2x equals to 4 plus 0.4x. So basically, x would be 5. And then I can see the peanut of the second box would be 1. The cashew of the second box would be 2. Okay, so how many pounds of cashew are now in the box? Well, I can see that this would just be 4, which is the final answer. So for the isosceles, I can just assume the 3 sides are A, A, B, and they should be positive integers. And I already know that one of the sides already has length 20, 25. So basically, we would have 2 cases. The first case, I can just have A is just 20, 25. And for the second case, I can have that B is 20, 25. Okay? Okay. And because 20, 25 is the longest side, okay? So I have that B must be smaller than or equals to A because A is the longest. So what can be B? Well, B can be from 1 to blah, 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 up to 20, 25. Okay? So there would be 20, 25 options for this case. Okay. How about the second case? In the second case, B is 20, 25. Well, let's apply the triangular inequality. I have that 2A must be strictly greater than B, which is 20, 25. As a result, A must be greater than or equals to 123. But also remember that 2025 is the longest side. So I have A is smaller than or equals to B, which is 2025. So I can see that A is bounded by these 2 terms. Okay, so then I have A can just be from 1023 to 2025, giving a total of 1023 options. Okay, so then I can see that 2025 options for case 1 and 1023 options for case 2. Does that mean I can just sum them up? No, because I am overcounting. Okay, I count the case of equilateral. I count the case of equilateral of side 2025 twice in both case 1 and case 2. So the final answer would be the sum of the choices of both case minus 1, which would be 37. Okay, which is D. So I can see that for this problem, there are two things we don't know yet. So I just set N to be the number of students and A to be the age of Ash. Okay, so what condition do I have? First, if Ash joins with the student, the average age will increase from 12 to 14. So what does that mean? Considering students, it would give us 12N plus A, which is the sum of the age of students and Ash would just be 14 times N plus 1. This is the purple condition. Okay, we also have another condition. If Ash plays with the teachers, the average age would decrease from 55 to 52. So what is the sum of the age of Ash and the teachers? Well, it would be 50 times 15 minus N. This is the sum of the age of the teachers plus A. Would equals to the sum of the age of the teachers and Ash, which is 52 times 16 minus N. Okay, and I can see that this is a system of linear equations with two variables. Solving this system, I can figure it out that N is just 7 and A is 28. So Ash is just at the age of 28. So first, let's observe the sequence. I can see that I can separate the whole sequence at each one into some subsequence, okay? And what is the shared pattern of each subsequence? First, it would always start with 1 and it would keep increasing every time increase by 1 up until the maximum of this subsequence, and then it would decrease by 1 until 2. So for the nth subsequence, it would just go from 1 to blah 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 n up to n plus 1 as the maximum, and then decrease from n plus 1 to 2. Okay. So how many terms are there in the nth subsequence? I can compute that it would have 2n numbers in the nth subsequence. So how can I know what is the 2025th term in the whole sequence? Well, to do that, I need to determine which subsequence 2025th term is on. So first, let's try to compute the cumulative length at the end of the nth sequence. Nth subsequence. So basically, I'm summing up an arithmetic sequence. 2 would be the length of the first subsequence, 4 would be the length of second subsequence, and it's arithmetic up until the last term would be 2n. And there would be n number in this arithmetic sequence. So it would be 2n plus 2 times n over 2, which is n times n plus 1. Okay, And in the end, I can see that 44 times 45 would be 22 times 90, which is 1980. Okay, so we are not there yet. And then I can also see that 45 times 46 would be 2070. Okay, 2070. So 2025, the 2025th term would be between would be right in the 45th subsequence. Okay, 2025th term is in 45th subsequence, because I can see that 45 is the first number such that n times n plus 1 is strictly larger than is larger than or equals to 2025. Okay. So what is the order of this 2025th term in the 45 sequence? I can see that it will just be 2025 minus 1980, which is 45. So it would actually be the 45th term, okay? The 45th term in 45th sequence. Okay. What would the 45th subsequence look like? It would just look like 1, 2, blah, 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 until the maximum 46 and then decrease to 2. So what is the 45th term? The 45th term would just be 45. So the answer is E. So basically, we would have an equilateral triangle such that all of its angles are trisected. Okay, and it would form this hexagon in the middle. So what are the angles of this hexagon? I can see that I would have this blue angle right here. Let's call it angle 1. Okay. By symmetry, I notice that actually these two blue angles are also angle 1. On the other hand, these three orange angles, they are also the same by symmetry again, and actually they are also equals to this angle 2. Okay, so how can I compute angle 1 and angle 2? Well, for angle 1, let's look at these two green angles. Okay, so I have angle 1 is just 180 degrees minus these two green angles, and we know that they would be 40 degrees by the trisection. So angle 1 would just be 100 degrees. What about angle 2? Well, for angle 2, let's focus on these two purple angles. And then I can see that angle 2 is 180 degrees minus 2 times 20 degrees, which is 100 degrees, 140 degrees. So what is the smallest angle? It's just 100 degrees. So the answer is C. Okay, before we dive into this problem, let's first look at a useful conclusion. Suppose I start with a high degree polynomial fx, and I divide it by a linear term, which is a first degree polynomial x minus n. What would I have? Well, I would have a quotient, let's call it qx, and I would have a remainder, okay? Let's call it r. So notice that because the divisor is first degree and the remainder must have less degree than the divisor. So our remainder would simply be a constant, okay? Would just be a number. So what does this mean? Well, this just means that fx is just qx, the quotient, times x minus n, the divisor, plus r, right? Okay. So let's try to set x is n. And then I have Fn. Would just be Q1 times 0 plus R. So which is just R. So if the remainder of x minus n is R, and then Fn would just be R. This is our useful conclusion. Okay, let's apply this conclusion to our problem. First, I have the remainder of x minus 1 is 4. So suppose I set this to be fx, lowercase fx. Then I just have f1 would be 4. But what is f1? f1 is 1 plus 1 plus a plus b, which is a plus b plus 2. Okay. Similarly, I can see that f2, because the remainder is 6, so f2 is just 6, which would be 8 plus 4 plus 2a plus b, okay, which is 2a plus b plus 12. Okay, so then organizing these two equations, I have a plus b is 2, 2a plus b is minus 6. Solving the system of linear equation, I have a is minus 8 and b is 10. Okay, so what is b minus a? And then I can see that the answer is just b minus a, which is 18, which is E for this problem. Alright, let's look at problem 8. So we would have 4 statements. Let's call the first one statement 1 as 1, second one as 2, third one as 3, fourth one as 4. Okay, so we have 4 statements, and let T be the number of true statements among these 4 statements. So what values can T take? Well, T can only be 0, 1, 2, 3, 4. Okay? And let's check our 4 statement. First, S1 says that at least one of the statement is true. So suppose T is to the right of this bar, okay? Then S1 is true. Same for S2. When there are at least 2 statements true, so suppose T is to the right of this bar of S2, then S2 is correct. For S3, at least 2 of the statements are false. So basically, it means that at most 2 of the statements are true. Okay? Because, yeah. So then I can see that at most 2 statements are true. So this would be the equivalent to whether S3 is true or not. Okay? So if T is to the right of this bar, then S3 would be true. If T is to the right of this bar, then S3 would be false. Same thing for S4. Okay. And then notice that I can pair the statements up. Suppose I pair S1 and S3 and S2 and S4. You can see that at least one of S1 and S3, at least one of S2 and S4 are true. So what does it mean about T? It just means that T is greater than or equals to 2. Okay, T is greater than or equals to 2. So then, as a result, I know that there are at least 2 true statements. So S1 is true, S2 is true. Okay, now let's check what can T be. Okay, suppose T is just 2. Then how many statements are true? Then both S3 and S4 are true as well. So there would be 4 statements are true, which is not 2. Okay. Suppose T is 4. Then you can see that there is an obvious contradiction. All four statements are supposed to be true, but S3 and S4 are not true. So we can only let ST to be 3, and in this case, F4 is true, but S3 is false, okay? So then T is 3. As a result, the number of false statements is just 1. So the answer is B. Alright, so we are looking for how many A does the graph of y equals to fx minus a pass through 125. So basically, we are looking for the number of solutions of 25 equals to f1 minus a. And as you can see, I can simply change it to the number of solutions to fx equals to 25. And by simplification, I can simplify fx into 100 times x times x minus 1 times x minus 2. So we can see that the original answer is equivalent to the number of solutions to a force equals to x times x minus 1 times x minus 2. Let's look at the three roots. I have the roots at 0, 1, and 2. Okay, so I can draw the diagram. Because the third degree polynomial has a positive x cubed coefficient, okay? Coefficient of x cubed, it would be 1, which is greater than 0. So what do I know? I know that to positive infinity, the function would go to infinity. To negative infinity, the function would go to negative infinity. So I can draw the diagram like this. From positive infinity goes to 2 at 0, and there would be a turning point so that it can goes to 1 at 0. And then there would be another point, and then it would go through the origin point, and then goes to minus infinity, okay? And this would be xy, okay? Coordinate of xy. All right, so what is the number of solutions to this function equals to a force? Basically, I simply need to check where is a force on the y-axis. First, I can see that. Let's check what is the value of a half. And you can see that if you just plug in a half to x times x minus 1 times x minus 2, you can see that it would be a half times minus a half times minus 3 over 2, which would be 3 over 8. Okay, so it would be 3 over 8, which is greater than a force. Okay, so this would be the line of force. Oops. So this would be the line of force. Y equals to a force. Okay. And you can see that there would be 3 intersection points of the green third degree curve and the purple line. So the final answer would be C. Alright, let's look at the diagram. You can see that for the smaller semicircle, I can simply translate it along AB or along CD and keep it tangent to CD. Okay, so I can basically translate it to the center of the large semicircle. Okay, so O would be the center of large semicircle, and it can also be the center of the small semicircle after translation. Okay, and I can see that the small circle is still tangent to CD. What does it mean? It just means that if I make the altitude from 0 to CD, let's call the altitude foot E. Okay, then the distance would just be the radius of the small circle. So OE would be R, which is the radius of the small circle. Okay, on the other hand, let the large circle have a radius of capital R. So OB would be capital R. And then what about OD? OD is also a radius, so OD is also R. Okay? So then I have OD is capital R and OE is lowercase r. With ODE, triangle ODE is a right triangle because angle OED by the tangent relation is 90 degrees. So what do I know? I know that r squared minus r squared is just DE squared. What is DE squared? CD is a chord in the large circle, so the altitude from the center of the large circle would land at the midpoint of CD. So DE would just be 16 over 2 squared, which is 64. Okay, now let's look at the shaded area. So then I have the answer, which is the shaded area is a half pi r squared, which is the area of the large semicircle, minus a half pi r squared, which is the area of the small semicircle, which is just a half pi r squared minus r squared, and I know it's 64, so the final answer is just 32 pi, which gives the answer as C.